What is the correct way to fix keyframes in FFmpeg for Dash? When conditioning a stream for Dash playback, random access points must be at the exact same source stream time in all streams. The usual way to do this is to force a fixed frame rate and fixed GOP length, i.e. a keyframe every n frames. In FFmpeg, fixed frame rate is easy, our number. But for fixed keyframe locations, GOP length, there are three methods. Which one is correct? The FFmpeg documentation is frustratingly vague on this. Method 1. Messing with libx264's arguments. There seems to be some debate if scene cut should be turned off or not, as it is unclear if the keyframe counter is restarted when a scene cut happens. Method 2. Setting a fixed GOP size. This is unfortunately only documented in passing in the FFmpeg documentation, and thus the effect of this argument is very unclear. Method 3. Insert a keyframe every n seconds, maybe? This is explicitly documented. But it is still not immediately clear if the time counter restarts after every keyframe. For instance, in an expected 5-second GOP, if there is a scene cut keyframe injected 3 seconds in by libx264, would the next keyframe be 5 seconds later or 2 seconds later? In fact, the FFmpeg documentation differentiates between this and the G option, but it doesn't really say how these two options above are the least bit different. Obviously, G is going to require a fixed frame rate. Which is right. It would seem that the force_key_frames would be superior, as it would not require a fixed frame rate. However, this requires that. It conforms to GOP specifications in H.264, if any. It guarantees that there would be a keyframe in fixed cadence, irrespective of libx264 scene cut keyframes. It would also seem that G could not work without forcing a fixed frame rate, R, as there is no guarantee that multiple runs of FFmpeg with different codec arguments would provide the same instantaneous frame rate in each resolution. Fixed frame rates may reduce compression performance, important in a Dash scenario. Finally, the keyint method just seems like a hack. I hope against hope that this isn't the correct answer. References. An example using the force_key_frames method. An example using the keyint method. FFmpeg Advanced Video Options section.
The answer therefore seems to be Method 1 is verified to work, but is lib264 specific, and comes at the cost of eliminating the very useful scene cut option in lib264. Method 3 works as of the FFmpeg version of April 2015, but you should verify your results with the script included at the bottom of this post, as the FFmpeg documentation is unclear as to the effect of the option. If it works, it is the superior of the two options. Do not use method 2, G appears to be deprecated. It neither appears to work, nor is it explicitly defined in the documentation, nor is found in the help, nor does it appear to be used in the code. Code inspection shows that the G option is likely meant for MPEG-2 streams. There are even code stanzas referring to PAL and NTSC. Also, files generated with method 3 may be slightly larger than method 1, as interstitial iframes, keyframes, are allowed. You should explicitly set the R flag in both cases, even though method 3 places an iframe at the next frame slot on or after the time specified. Failure to set the R flag places you at the mercy of the source file, possibly with a variable frame rate. Incompatible dash transitions may result. Despite the warnings in the FFmpeg documentation, method 3 is not less efficient than others. In fact, tests show that it might be slightly more efficient than method 1. Script for the force_key_frames option. Here is a short Perl program I use to verify a frame cadence based on the output of an NBSP SLHCK's probe suggestion. It seems to verify that the force_key_frames method will also work, and has the added benefit of allowing for scene-cut frames. I have absolutely no idea how FFmpeg makes this work, or if I just lucked out somehow because my streams happen to be well conditioned. In my case, I encoded at 30 FPS with an expected GOP size of 6 seconds, or 180 frames. I used 180 as the GOP size argument to this program verified an iframe at each multiple of 180, but setting it to 181, or any other number not a multiple of 180, made it complain.
TL drive. I would recommend the following. Lite 264, gx_keyint_min_x, and optionally add force_key_frames x per column gtet, n_forced_n. Lite 265, x 265 params, keyint equals x column min keyint equals x. Lite vp9, gx, where x is the interval in frames and n is the interval in seconds. For example, for a 2-second interval with a 30 fps video, x equals 60 and n equals 2. A note about different frame types. In order to properly explain this topic, we first have to define the two types of iframes, keyframes. Instantaneous decoder refresh, IDR frames. These allow independent decoding of the following frames, without access to frames previous to the IDR frame. Non-IDR frames. These require a previous IDR frame for the decoding to work. Non-IDR frames can be used for scene cuts in the middle of a GOP, group of pictures. What is recommended for streaming? For the streaming case, you want to ensure that all IDR frames are at regular positions, for example at 2, 4, 6 seconds, so that the video can be split up into segments of equal length. Enable scene cut detection, so as to improve coding efficiency, quality. This means allowing iframes to be placed in between IDR frames. You can still work with scene cut detection disabled, and this is part of many guides, still, but it's not necessary. What do the parameters do? In order to configure the encoder, we have to understand what the keyframe parameters do. I did some tests and discovered the following. For the three encoders Lite 264, Lite 265 and Lite VP9 in FFmpeg. Lite 264. G sets the keyframe interval. Keyint_min sets the minimum keyframe interval. X 264 params keyint equals x column min keyint equals y is the same as gx keyint_min y. Note, when setting both to the same value, the minimum is internally set to half the maximum interval plus 1, as seen in the X 264 code. Lite 265. G is not implemented. X 265 params keyint equals x column min keyint equals y works. Live VP9. G sets the keyframe interval. Kint_min sets the minimum keyframe interval. Note, due to how FFmpeg works, Kint_min is only forwarded to the encoder when it is the same as G. In the code from livesync.c, in FFmpeg we can find this might be a bug or lack of feature, since Live definitely supports setting a different value for kf_min_dist. Should you use force_key_frames? The force_key_frames option forcibly inserts keyframes at the given interval expression. This works for all encoders, but it might mess with the rate control mechanism. Especially for VP9, I've noticed severe quality fluctuations, so I cannot recommend using it in this case.
Here is my 50 cents for the case. Method 1. Messing with looks264's arguments. CV looks264 x 264 ops kint equals gopsize min kint equals gopsize scene cut equals 1. Generate a frames only at the desired intervals. Example 1. Generate a frames is expected like this. Method 2 is depreciated. Omitted. Method 3. Insert a keyframe every n seconds, maybe. Force_key_frames expr GTT, and _force GOP_lun_n_seconds. Example 2. Generate in a frames in a slightly different way. As you can see, it places a frames every 2 seconds in on scene cut, seconds with floating part, which is important for video stream complexity in my opinion. Generated file sizes are pretty the same. Very strange that even with more keyframes in method 3 it generates sometimes less file than standard x264 library algorithm. For generating multiple bitrate files for HLS stream we choose method 3. It perfectly aligned with 2 seconds between chunks. They have a frame at the beginning of every chunk and they have additional frames on complex scenes, which provides better experience for users who has an outdated devices and cannot play back x264 high profiles. Hope it helps someone.
I wanted to add some info here since my Googling pulled up this discussion quite a bit in my quest to find info on trying to find a way to segment my dash encoding the way I want it, and none of the info I found was totally correct. First, several misconceptions to get rid of. Not all iframes are the same. There's big iframes and little iframes. Or to use correct terminology, iter iframes and non-iter iframes. Iter iframes, sometimes called keyframes, will create a new GOP. The non-iter frames will not. They are handy to have inside of a GOP where there is a scene change. x264 ops keyint equals cop size column min keyint equals cop size. This does not do what you think it does. This took me a little while to figure out. It turns out the min keyint is limited in the code. It is not allowed to be greater than keyint 2 plus 1. So assigning the same value to these two variables results in the value for min keyint getting knocked down by half when encoding. Here's the thing, scene cut is really great, especially in video that has fast hard cuts. It keeps it nice and crisp, so I don't want to disable it, but at the same time I couldn't get a fixed GOP size as long as it was enabled. I wanted to enable scene cut, but to only have it use non-iter iframes. But it wasn't working. Until I figured out, from lots of reading, about misconception number 2. It turns out I needed to set keyint to double my desired GOP size. This means that min keyint can be set to my desired GOP size, without the internal code cutting it in half, which prevents scene cut detection from using iter iframes inside the GOP size because the frame count since the last iter iframe is always less than min keyint. And finally, setting the force _ key _ frame option overrides the double size keyint. So here's what works. I prefer segments in 2 seconds chunks, so my GOP size equals frame rate 2. You can verify using FFmpeg. In the generated CSV file, each line will tell you frame is _ and _ iter _ frame _ type, frame _ number. The result is that you should only see iter iframes at fixed GOP size intervals, while all other iframes are non-iter iframes inserted as needed by scene cut detection.
If you want to support the channel, please action figure subscribing.